We're now going to take using first principles one step further, and first we're going to find the gradient of the whole curve, and then we're going to find it at a particular point. So our example is find the gradient of the tangent at the point 6, 6 of the curve y equals x squared minus 7x plus 12 using first principles. Now if you think about that curve, it's a parabola, it's concave up, and if we try and factorise it, that's x and x minus 4 and minus 3. So if we find the roots are at the points 3 and 4. So if I plot those and just do a rough sketch, and if that's the point 4 and that's the point 3, I want the tangent at the point 6, that line there. So we can see that gradient is going to be a positive, so we're expecting a positive number, and we're finding it at that particular point. So f of x is our y curve, which is x squared minus 7x plus 12, and f of x plus h. So whenever we see an x, we put an x plus h. So x plus h all squared minus 7x plus h plus 12. Let's expand that out. So x squared plus 2xh plus h squared minus 7x minus 7h plus 12. And I can't add in like terms there. So dy dx, I'll do it quite small so it'll fit, equals the limit as h approaches 0, x squared plus 2xh plus h squared minus 7x minus 7h plus 12 minus, in brackets, x squared minus 7x plus plus 12 all over h, which is the limit as h approaches 0. Now, you can see that because of the minus here, these signs are going to cancel and everything without the h cancels out. So x squared minus x squared, that's a minus 7x, and that's now a plus 7x. They cancel. 12 minus 12. So what we're left with is 2xh plus h squared minus 7h all over h. So we're going to take h out as a common factor, get rid of the denominator. So it's h outside of 2x plus h minus 7 on h. The h's cancel. I'll just do it here. So it's the limit as h approaches 0 of 2x plus h minus 7. Now we can just sub h in. So dy dx equals 2x plus 0 minus 7, which is 2x minus 7. And now if x equals 6, doesn't really matter what the y equals, if x equals 6, we know that dy dx equals 2x minus 7, and just sub the x in. 2 times 6 minus 7, 12 minus 7 equals 5, which is what we predicted, that the gradient would be a positive gradient. If we have a look at that curve again, there's 3, there's 4, and 6 is here. So it has a gradient of 5.